At this point, I want to introduce you to Portia Burton. She's going to be doing our next talk. She is the founder of her own company, PLB Analytics, and she's going to be talking to you about knowing thy neighbor. So, there you go.
Okay. Let's begin. Yes, I do. Oh, no. Here we go. Hello. Once again, my name is Portia Burton, and I am going to forewarn you that this is going to be a very beginner lesson on Scikit-learn and KNN. So a little bit more about me. I am organizer of the Portland Data Science Group. We're a great group of local people who talk about data visualization, we talk about database technologies, and we have a lot of fun together. I'm also a volunteer of an organization called Hack Oregon. Hack Oregon takes campaign data and we make it more accessible for people who are interested in committees and campaigns and how money is flowing in the political system. And finally, as you already know, I'm also founder of a company called PLB Analytics. We're going to cover a lot today, so let's get to it. Brief introduction to machine learning is the first thing that we'll talk about. We'll go over the Python machine learning package, Scikit-learn. We'll explain the k-nearest neighbor algorithm in a bit more detail. We'll have a demo of Scikit-learn and KNN. We'll explore the sample script. And the next step. I'm not going to talk about the next step yet. So machine learning. What is machine learning? Simply, it's when the algorithm is learning from the data that you're giving it. It's responsive to the data. The algorithms use the data to create predictive models, to classify unknown entities. That's something that we will be doing today. And discover patterns. And this is just a sample of some of the things that you can do with machine learning. There are other activities as well. Here is the basic workflow of machine learning. This is basically how I do my work. 70% of my time is spent cleaning and standardizing the data. 20% of my time is spent pre-processing, training, validating, and then comes the fun part, which is the 10%. No, this is cool. Where I get to analyze and visualize and pretend I know D3 JavaScript. Scikit-learn. So once again, Scikit-learn is Python's answer to machine learning. It's great. It's a machine learning package. It has great documentation. Actually, a lot of this presentation is basically an ode to Scikit-learn documentation. And it has built-in data sets. So if you're new to machine learning and you don't want to go out and hunt for your own data set, you can use the data sets provided for you by the Scikit-learn documentation, such as the Boston housing market. However, after the presentation, if you're interested in hunting data sets, then I actually have some places that you can go to. I spend a lot of time hunting data sets. Let's say that you have, this is a great illustration that you will find in the documentation. Let's say that you're given a machine learning task and you do not know exactly where to begin. This will be great in helping you figure out what you should do. So a question you should ask yourself is, how big is your data set? If you have less than 50 samples, then you should probably go and get some more data if you can. And you have to figure out, what do you want to do? I mean, what kind of problem do you have? Do you have a classification problem, clustering, regression, or dimensionality reduction? Once you figure out what your problem is, then you can play around with the different algorithms. For today, we are going to deal with a classification problem, and the person presenting, Sarah, the person presenting after me, you'll get a chance to see what to do during a clustering problem. Many companies, organizations, non-for-profits use Scikit-learn, one of them being Evernote. Evernote, you're familiar with Evernote. Basically, you can take a website and turn it into a note. When you turn it into a note, you have the option of putting it inside a notebook. Before you put it inside a notebook, Evernote tries to make a guess on which notebook to put it in. That is, suggesting notebooks is a classification problem, and it implements the naive Bayes classification algorithm. I should say Evernote did use Scikit-learn. I think Evernote actually uses Java now. It's in there. They have a blog post about it. You can read it later. Here is naive Bayes classification algorithm. And if you're beginning with machine learning, you will come across supervised and unsupervised learning. Unsupervised learning is simply when the data points are not labeled with outcomes. If you're looking for bins to put it in, the patterns are actually found by the algorithm as opposed to by the person himself. Supervised learning, which is what we're going to do today, your samples are already labeled. There are two different types of supervised learning. There's classification, where you have categorical data, and there's also regressions. Regressions use continuous data. And here is the theoretical model for supervised learning. With supervised learning, you take your features, you pick the features that you feel are the most predictive, and using those features, you're able to come up with an outcome. Remember when you are making your model to keep your sample size high, but you want to keep your feature set low. You want to keep your sample size high, but your feature set low because you want to prevent overfitting and noise. Here are some examples of supervised learning that you might have come across. Handwriting analysis. Spam filters. Oh, I'm glad you find it amusing. And now it's time to talk about the KNN, K nearest neighbor algorithm. The K nearest neighbor algorithm is considered the simplest machine learning algorithm. It is a lazy algorithm, which means it's not active and it doesn't run computations on a data set until you give it a new data point. That is not true for all machine learning algorithms. And our examples will use KNN for supervised learning. Problem number 1, mystery fruit. Let's say you have several apples and several oranges, and you have an unclassified fruit. In this case, we are going to set our K to 3. We're going to look at our 3 nearest neighbors. And using this information, we are going to predict, or we're going to identify our mystery fruit. So using K as 3, our mystery fruit is most likely an orange. Pro tip, whenever you're setting K, please try to use an odd number. You don't want to be in a situation where K is 4 and you have 2 apples and 2 oranges and you're not sure which one to use. So keep your K odd for the most part. Majority vote. There are 2 ways that you can control majority vote. Majority vote can be equal weight, which means each KNN neighbor has an equal weight, Or it could be distance weight. Distance weight is where each K and N neighbor's vote is based on distance. K and N uses Pythagorean theorem. So yes, middle school math is useful after you graduate. Here are the downsides of K and N. Downsides is, since there is minimum training, there is a high computational cost in testing new data, and the correlation can be falsely high, which means the data points can be given too much weight. Live demo time. Before we do our demo, I hate to break the flow of this presentation, but do you have access to my GitHub repo? Yes? Did you already clone the materials? Yes, great. Okay, so if you can just go to the KNN. Oh, were you not given a link? Okay. Of course not. Okay. Oh, okay.
Can you put up one? Can you put hers on back on one screen?
Okay. So if you go to this link, you'll get the materials for this presentation. I'm sorry I didn't give that to you earlier. And all you need to do is a git clone, and that will give you the IPython notebook. So I'll give you several minutes to clone the materials. Oh, goodness. See how you're doing. Oh, is that what you got? Yes.
This one, okay.
Yes.
Awesome, thank you.
Thank you. Yeah. Yes. I'm not sure exactly where it is, but it is in documentation where you can find out how long it takes. I've done.
Random forest once and 5 hours later.
Yeah, that's a bit of a problem. But no, it's in there, and we can look for that afterwards. Is everyone? So is everyone able to get the notebook up and running? Yes? Okay. So you're looking for we're going to go to KNN PyCon 2014.
PyData 20.
Really? That's interesting. Okay. Oh, yes, PyData. So PyData 2014, yes? Critical mass? Good. Excuse me. Great, thanks. So, I hope I have your attention. Some of you, that's okay. I'll take some. Our data set, we're going to use irises. Some of you will say, oh no, not irises. Irises is actually a classical data set that if you've dealt with machine learning, then you've come across this. I'll give you some information about the iris data set. It's typical. And it's actually older than Python. It's older than you. It was actually created in 1936. It was analyzed by Sir Ronald Fisher, but it was collected by Edgar Anderson. So that's a little bit of historical information about the famous iris data set. Our job is to classify which type of iris that we have based on the length and the width of the sepal and the petal. And to give away the ending, this is what you should have when you run the whole code. The dots are actually the training data. And the pink, green, and lilac is where your decision points, your decision lines are located. That's your test data. See, is there any other information I should give you? And these are the different type of irises that we have in our data set. At this point, we're going to go to IPython, to PyData 2014. We have all of our packages, NumPy, PyLab, Matplotlib, Scikit-learn. We are going to set our neighbors to 30. And we are going to load our data set, which is the iris data set. Yes? You're right. Thank you. Thank you. That was a test. No, it wasn't at all. It was an honest mistake. Thank you. So 31. And we're going to load our iris data set. And what I like to do is we're actually going to print the shape of our data set. The X information gives you how many samples we're dealing with, and 2 is telling you how many features we're looking at. So we're looking at 2 features. We're going to create our mesh. And in this section, we're going to classify. We're going to fit our data set. And then we're going to predict. And after we set our X and Y axes, voila. Now, if you notice, Figure 1 and Figure 2 is different. And the reason why there's a difference is because of our parameter weights. In Figure 1, our weight is uniform. And in Figure 2, our weight is distance. So what I'd like you to do is, we're going to break the rule again. Actually, I would like you to set your neighbors to 149 and see what happens. So set your neighbors to 149. Your neighbors was 31, set it to 149. Yes. Can you say that again, please? Yes. When you say classes, are you talking about the feature set, the features? Huh?
Like you gave the diagram, you saw you had 3 different classification.
Yes.
Right? So 3 class classification. So in that, if you have like, if you put k equal to 33, still you can have like.
Yes, you're
just
right.
saying that.
The problem will you have 11, 11, 11.
Yeah. So it's like.
Thank you.
I'm just saying it's 2 class, it's fine, but for 3.
Oh, I see what you mean. Thank you. Did you change the neighbors to 149? Yes. And what did you get? 2? Oh. Okay. Oh, so 149 gives you 2. If we set our neighbors to 149, let's check this. Give me one moment, please. The reason why you get 2 classes is because there's less green than red and blue. So the amount of your test data is overwhelmed. The amount of your red and blue test data is actually overwhelming the green. And if you notice, because you have distance, green is closer than the red and blue. So that's why you have a decision point, which is green as well. Okay. This section of the presentation is finished. Are there any other questions before we go on to the second part? I am not sure. That's something I would have to try out and write down. Any other questions? No, silence. Now it's time for the second part of our presentation. References. Okay, now what? I don't know about you, but personally, I go to a lot of conferences, and I go to a lot of meetup groups. I learn a skill. I sometimes do it well during the actual session, but then after the session or after the class, I never pick it up again. Or I pick it up 6 months later. And I'm going to try to stop that from happening today. So I can't talk about time management. I mean, that's up to you. But I can give you a suggestion on where to go to now if you want to improve on machine learning or if you want to find more machine learning problems. Helpful hints are not beyond the scope of this presentation. If you want to know more, what we're going to do today is, oh wow, that's not there. These are the blogs that I look at. I stalk people. If you have a blog, if you have information on pandas or Scikit-learn, I will be looking for you and I will be citing you. So that's one way to go about it. And the second way is Kaggle. Have you ever heard of Kaggle before? I think most of you have. Yes. Kaggle's great. I've started Kaggle about 2 or 3 weeks ago. When I'm learning a new skill, I usually make my own product or project. I contribute to open source, but Kaggle is another way that you can learn a skill, and it's just another option. So what we're going to do today is we're actually going to start on a Kaggle problem. So I'm going to do an introduction on what Kaggle is, and then I have another notebook that's dedicated to the Titanic data set that we're going to start today. So for those of you who do not know Kaggle, Kaggle is basically machine learning competitions. Can you see that? And the great thing about Kaggle is not only are you practicing different algorithms, but you have different motives. Like you can go into a competition and you can compete for money. You can compete for a job. Or you can go to a university, I forgot which university has data sets, and you can play around with their data set and learn more about different algorithms. So what we're doing today is we are going to look at the Titanic data set. So what I would like you to do is, let's see, give me a moment. Kaggle, Titanic. Excellent. So there are two things. One, if you can navigate to the Kaggle Titanic Getting Started, go to Get Data, and you will be testing and training based on the data files. Before you actually get into the machine learning part, could you open the Kaggle IPython notebook? There are 6 challenges. So I'd like you to spend the remaining part of the time working on the 6 challenges using this data set. And this is a good way for you to get started with Kaggle. So I'll leave you some time to do that now. Which one? Give me a moment. Underscore. Oh, I'm sorry. Yeah.
I don't know if am I going to need PyLab for all of the notebooks? Because I'm still on the previous one. I'm not, it appears that I need to install it. Let's see here. So we're doing Kaggle rig. But let's see, is this am I going to need PyLab for these?
Not for the first ones, no. You'll need pandas.
Okay.
Yeah. Yeah, for the first 6, just to do pandas. Oh. I'm sorry. Okay. I like honesty. Oh, I'm just around for help. Okay. Yeah, that's the training, and that's also the testing data. And first, you're going to load the TSVs into your notebook. So that's task 1. So task 1 is loading your testing and training data into your notebooks. And if you need any help, you could just raise your hands. I think you would have to get that separately. Do you have Matplotlib? Conda's the best way to go. Like I tried pip install, and I've gotten a lot of dependency issues.
So if I have installed, because I thought I ran Python off of, how does that stop?
Right.
So should it have been there automatically, or
I am not sure. Actually, I can look that up. Excuse me. Say it again? I think you can download it from there. Yeah, then I went and sign in. Okay. Well, first you go to the. Well, first you go to.
I got the data sets.
Okay, and it's in there. Where is the directory of your IPython notebook? So you're going to put your data sets in the same directory as your notebook.
Right.
One moment. Oh, I didn't let you know this, but if you look in my GitHub repo, there's actually a README sheet. It's not a cheat sheet, but it's different sites you can go to help you with the questions.
I'm also wondering if my notebook setup is right, because this doesn't show anything. Just kind of like seems to hang there.
Can I see, please?
Yeah.
Sometimes when you're using IPython, you have to go like / pylab and then notebook.
Okay.
That's something I learned like 2 days ago.
That's just because I don't have it on my computer.
Oh,
I think it's fine.
wait a second. So where are your notebooks? Here. So I would go to PyData. And you're not getting an error for. Let me check my computer. So try this. It would be notebook, IPython notebook / like PyLab equals inline.
Oh, okay.
Yeah.
Hold on a second. We have 6 minutes.
Okay.
Minutes for questions.
Let's have this question about IPython notebook.
Okay.
You said we were supposed to collect the data.
Yes.
Notebook, the worksheet into like a data frame. Do you mean just in a folder?
It's in a folder in the same directory as your notebook.
Oh, okay.
Yeah.
And my question is, why can't I seem to navigate within my directories?
Okay. All right. All right, we're going to finish up in the next 4 minutes or so. So if there are any more questions, now is your chance. Hey, what's going on? Oh. Say it again? Oh, okay. Is everything clear? Yeah. Okay. Just making sure. You know about what?
I didn't know about that data set.
The Titanic one? That's fine. If you're, there's Krishna Shankar did a great PyCon tutorial on Titanic and Kaggle. It's 3 hours long, but it's the best tutorial. It's 3 hours well spent. Yeah. Oh. It's actually. So if you want more information about Kaggle and the data set, I would suggest looking at Krishna Sankar's presentation on Kaggle and data science. It's 3 hours long. It's one of the best 3 hours that you can spend looking at a tutorial. It was presented at PyCon 2014, and that information, the slides and the video should be in the repo, in today's repo that I gave you. Okay, this is the end of the presentation. Thank you for joining, and I hope you continue with Kaggle and Scikit-learn.